In this video, I will explain how to name ionic compounds that include monatomic anions. Here is a flowchart that highlights the naming conventions for all inorganic compounds that you will encounter in Gen Chem 1. This video will focus on the highlighted boxes shown here. Inorganic compounds can be categorized as either ionic or covalent. Ionic compounds usually contain two components, a metal cation and a non-metal anion. I will discuss ionic compounds. Ionic compounds can be broken into two categories, those that contain monatomic anions and those that contain polyatomic anions. Monatomic anions include atoms of a single element, while polyatomic anions contain atoms of multiple elements. I will limit this presentation to ionic compounds with monatomic anions. There are two categories of ionic compounds that contain monatomic anions, those that are acidic and those that are not. Let's start with compounds that are not acidic. First, we write the name of the cation. You do not alter this name in any way. Usually, the cation is a metal, such as sodium, potassium, or calcium. Next, you write the root of the anion and attach the suffix "-ide" to it. Here is a list of common anionic roots. Let's look at one example, LiCl. The cation is the metal lithium, and the anion is the nonmetal chlorine. We begin by writing the name of the cation, lithium. Next, we name the anion. Take the root of the anion, chlorine's root is chlor, attach "-ide" to this root and you get chloride. So this compound is named lithium chloride. Here's another example, CaF2. The cation is calcium and the anion is fluorine. Name the cation, calcium. Then take the root of the anion, fluor, and stick "-ide" to it, which makes fluoride. This compound's name is calcium fluoride. If the cation is a transition metal with multiple potential oxidation states, you must indicate the oxidation state with Roman numerals within parentheses after naming the cation. Follow the same steps from before for the anion. Name the anion root and attach the suffix "-ide" to it. FeS is one example of this. The cation iron can have the oxidation states +2 or +3. Because sulfur has a -2 charge and the overall charge of this compound is 0, iron must have a charge of +2. So begin by writing iron with a Roman numeral 2 in parentheses. Then take the root of the anion, sulf, and stick "-ide" to it, which makes sulfide. This compound's name is iron sulfide. Some ionic compounds have water molecules trapped within their crystals. They are considered hydrates. These compounds follow the same naming conventions as described earlier. Following the ionic component is an interpunct followed by a specific number of H2Os. Find the prefix that matches the number of H2O molecules present and attach the word hydrate. Here is one example, BeI2 8H2O. The cation is beryllium and the anion is iodine. We begin by writing the name of the cation, beryllium. Next, we take the root of the anion, iodine's root is IO, attach "-ide" to it and you get iodide. There are 8 water molecules present within these crystals, so attach the prefix "-octa" to hydrate to make octahydrate. The name of this compound is therefore beryllium iodide octahydrate. Here is a summary of the naming procedures for non-acidic ionic compounds with monatomic anions. Next, we'll look at acidic ionic compounds with monatomic anions. The naming begins with the prefix hydro, followed by the anionic root, which is attached to the suffix "-ic". This is followed by the word acid. HCl aqueous is one example. In order to be acidic, an ionic compound with a monatomic anion must include hydrogen and exist in the aqueous phase. Begin with the prefix hydro, list chlorine's root, chlor, and attach the suffix "ic" to it. End this with acid to name this hydrochloric acid. If the aqueous phase is not indicated in ionic compounds containing monatomic anions, do not name this compound as an acid. Instead, treat it as a non-acid. Hydrogen is a cation, so we will begin with hydrogen and attach the anion root to "ide." For example, if HCl is presented without an aqueous phase label, name it as if it was not an acid. Begin with the cation, hydrogen. Plug in chlorine's root, chlor, and attach the suffix "ide" to it to make hydrogen chloride. Here are all the naming protocols for ionic compounds with monatomic anions, and here is a summary of all the naming procedures. My next video will cover ionic compounds with polyatomic anions.